All right, I'll go ahead and get started here. Welcome to NX PMI for designers and engineers. This is NX 10 PMI overview. I'm Matt Martin from Applied CIX. I'm a applications engineer and mechanical designer. So what is PMI, a model-based definition? Well, PMI is NX's application of model-based definition. So it allows you to document your model in 3D with dimensions, notes, process specifications, finish, material, and the like, allowing you also to place GD&T, geometric dimensioning and tolerancing, as well as use that PMI in downstream applications. We'll cover a little bit of that too. So a lot of terms you hear when you get into PMI is paperless. Paperless has been an initiative that's been around since I've been in this industry my entire career, and I rarely see that a company is able to go completely paperless. However, there's less paper today than there was when I first started. Paperless does not necessarily mean drawingless. Going with 3D PMI does not require you to commit to going with a drawingless approach. However, it is a tool to help you enable to go into drawingless. So what are the benefits of adopting PMI, a model-based definition? You can enhance your design cycle by allowing people to see how the part is being put together, what the specifications are, early in the design cycle. It's not just for a single part, you can do it with an entire assembly. And it allows others in the enterprise to be able to see the designs, where it's going, and how it's going to be used. You can more accurately capture the design intent, thereby reducing the amount of rework you end up with. A 3D annotated model, and well, as we'll see, is a little bit easier to identify exactly what the dimensions are intended to convey. And at the end one here is it increases productivity by allowing everyone to see the product early and where it's going. And of course, like with anything in the engineering world, there's a bunch of standards that can be referenced for how to apply 3D model definition. The biggest one, and the one I'm most familiar with, is the ASME Y1441, a 3D digital product definition. There is also the more of a metric international standard, the ISO, and one specifically for the Japanese market, the JADA 3D annotated model guidelines. These are available online for purchase and download in various places. It's a quick Google search to find them, but you can use this to help guide your processes. NX does conform to the standards that are published in these guidelines, and as we'll see coming up. So PMI is not just for documentation, although it may make my life a little bit easier as a designer to apply 3D PMI and make my 2D drawing cycle a little bit shorter. There's other things you can use the PMI for. First and foremost is a collaboration. You can share the model with 3D PMI on it and show the intent of the model on how it's going to be produced, the tolerances that it has to reach, and other people can see that in your supply chain. You move it to the next phase where you're going to get the part manufactured. CNC manufacturing can consume certain bits of the information in the PMI world and allow you to reduce your programming time. You can also use PMI in variational analysis. Variational analysis is a tool that Siemens has that allows you to bring in the lightweight data with all the PMI and do assembly configurations. You put part A to part B and look at the stack up. You can obviously do this with multiple parts, and it's much more effective than hand calcs or having a little spreadsheet that does your stack-up analysis. You can also do assembly process planning, again with visualization tools. You can show people how things go together. CMM inspection can consume the PMI and reduce your programming time using NX CMM. And you can always take that the PMI that's on your 3D model and pull it into 2D drawing. So you're not going into a dual documentation environment. You can just consume the 3D PMI. So NX saves time downstream. You can, by using the VSA toolkit, you can save, that's a visualization tool from Siemens. You can save up to about 50% in the analysis setup because it's going to consume all that PMI and you don't have to type it in from a 2D drawing. NX CMM can leverage PMI and bring in tolerances, surface finishes, and can save your programming time by up to 80%. That can be quite significant if you're in a place where you're inspecting a large majority of the parts that are coming in. NX CAM can consume dimensional tolerance and surface finish information as well as the threaded hole information, saving programming time. And you can collaborate with the entire supply chain with using PMI and JT with solutions like JT2Go, Express Review, and Team Center Visualization. Those are Siemens products. JT2Go and Express Review are free, while Team Center Visualization is a licensed tool and has a lot more capability. There's other tools out on the market as well. I'm not going to cover in this webinar, but just a Google search, you can find a lot of JT-related tools. In fact, starting in Windows 8, JTs can be visualized just in Windows. You can reduce the time to create 2D drawings by placing PMI that's been placed on a 3D model into the drawing. So who's using PMI? Aerospace has been using PMI for a long time, even before it was really a standard. Orbital ATK recently published that they were able to save up to 30% in drawing preparation time, and they are successful in their implementation throughout their supply chain to get their supply chain to just accept the 3D annotated models and no 2D drawings. General Motors is currently using NX PMI in their new vehicle programs, and they're currently training up the entire the global supply chain. And most of what they're using right now is in North America. And out there in the news, is PMI the drawing killer? It's been talked about for quite a few years. This is an article that's been referenced by others and discusses where PMI is going. And Siemens PLM looks to be the way forward and is a very powerful tool for documenting your parts in 3D PMI. So where are you today in your company? You could be anywhere from just starting, have no idea what PMI is, all the way through your entire enterprise is engaged in PMI and model-based definition. The National Institute for Standards and Testing, NIST, has developed a website called modelbasedenterprise.org. And there's a bunch of tools up there to give you access to where the standards are. There's some MIL standards. There's also some good supplier assessment reports up there. Discusses which suppliers are ready for PMI and what percentage of the supply base in America is accepting that 3D model definition. And with the analysis tools, you can completely analyze your enterprise and figure out where you are. Everything from essentially board drafting, where there's no model and drawing connectivity, all the way through the entire enterprise is enabled, automatic generation of your data package out to your suppliers, and no drawings are even allowed. So there's 6 or 7 levels, starting with level 0, and the tools are available up on the NIST website to determine where you are in the model-based enterprise realm. So with that, I'm going to switch over to NX. And go with the live demonstration. Here I have a part that, so to make sure no one's asking questions and chatting here. Okay, that's good. Here I have a part with a little bit of a model-based definition already applied to it. The basics of PMI is I have a PMI toolbar up here where I have a toolbar that's very similar to what you would see in drafting. I can place dimensions, notes, feature control frames for GD&T, my datum control symbols and targets, surface finish, and the list goes on. The nice thing about PMI is that there's a few extra tools in here that kind of help you out in the design cycle and documentation cycle. PMI is based on what model view you are creating them in. Out of the box settings are set up to apply it to the model view that you're working in. So if I switch this to front, I see that I have no PMI in here. And if I want to place a dimension between these two holes and pull it out, then I have a dimension that's been created between those two holes. Quick and easy. And it's been placed on the model view itself. So my front view is the work view, and I have a node here that shows that I placed the dimension on here, and it's a linear dimension. It's actually being tracked. If I want to show that in multiple views, I can just right-click on that instance, and I can display it in all views, or actually this one's set to display on all the views already. So I can uncheck all the views I don't want them to be in and just leave it in the front. That's my view right now. So now when I go to a back view, I don't see that same dimension. Go back to front. And there's my dimension again. And I have a PMI work view here that shows more PMI in more of an ISO view. One of the nice things about working with PMI, though, is if I have a note here, or rather a dimension that's calling out that this is an M5 hole, I can go in and have selected objects so that when I highlight this note, it tells me exactly what it is that I'm talking about. So it's easier to identify what the 2x is actually telling me on the screen. Again, with the counterbore note that's down here, right now it's just attached to one edge. But what I would rather have it do is attach to all three of these counterboard surfaces. Now when I highlight that, it goes in, shows me all three of those are for the counterboard surfaces there. And if I want to see what datum C is all about, I can see that it is this entire face on this end here. Now this model has a lot more PMI that's not even being shown on here, so I'm going to show it all. And it kind of gets a little bit messy because this particular one is showing all the PMI from a lot of the different views in this, also in the PMI work view. But it's a pretty nice overview of everything that's in the part, and you can adjust how it looks in space. Let's rotate that back to where I can see what's going on. Other thing about PMI, and it's a preference setting, is that as I rotate the model around, my PMI will also rotate around, so it's always visible to me. And you can see PMI, and sometimes this can be a bit distracting. You can actually see the PMI through the part. This is another setting that you can change if you don't want to see it through the part. Sometimes it's getting so dense that it is a bit distracting. It's a little hard to pick up on exactly what you're trying to find in there. So here's a relatively simple part. Place some PMI on it. I'll throw another dimension It tells me that it's read-only. I have it released in the system. And I throw a quick dimension on there, see what my work view is. My work view is the front view, although it's sitting in kind of an ISO view. So as a front view, that dimension probably doesn't really give me much information that I need. So I'll place another dimension out here. And I want to see what this looks like in a drafting view. So I'm going to go ahead and inherit this into a drawing. I'm going to go ahead, I'm going to cancel my view creation wizard and just place a base view. And all those views came from the front, and if I just look at it this way, I don't see any of my PMI on it. I can go into settings, the PMI node, and right now the PMI is set to none. I can tell it to give it to me from the model view, view only, or the entire part. So there's model view, and from that I can pick the things that I want to show in this particular view. So if I don't want to see weld symbols, maybe that's going to be in a different view, or I don't want to see coordinate notes. I can uncheck the things that I don't want to see and then place that on there. Now, it didn't automatically show up, and there's a reason for that. In this particular model, if I look at all my PMI is actually sitting on a different layer. So I'll go back up, turn off all this, and I'll turn on all my other layers, and again go into base view, do a front. And when I place it, the PMI shows up. Now the PMI that shows up in the drawing view is I can edit it and move it around, and it only affects the view that it's in. So in my drafting view, this is the only place that's going to affect it. So if I drag these out like this and kind of arrange it the way I want it to look, when I go back into the part itself and into modeling, those dimensions are still where they were in 3D space. So you're not really affecting it, the location of where they are, back and forth. You're just making it so it's more visible in a 2D realm than in a 3D realm. Other things I can do with PMI, I'll go back into modeling here. PMI is a modeling application, so you're not really in drafting anymore. Is I can place in just a general note. So the general note is associated to the model view. Under orientation here, I just have it set to the model view. And I can have a note in here that this is aluminum. But I can also put in different kinds of notes that automatically pull that information in. Some of the other notes that I can put in here are like a government security information note. And these are out of the box. They're pre-configured, but you can create new ones specific to your organization. So I can have government purpose rights, limited rights for software. And if you're working with government agencies, this could be something that you're interested in. And when I place that on the drawing, you'll notice that the government security information is now grayed out. I place a proprietary information note on here. So I have, this is proprietary for internal use only, proprietary for external use. Maybe this is a part that I want to have just inside the company, and I can use stacking like I can in drafting and place that note on there as well. And that one also gets grayed out. And one that is becoming more and more important if you're an ITAR company is that you need to identify your parts as whether or not they can be exported or not. So if this is a export controlled no license, export controlled with a license, or no export control at all, Maybe this is a part that does not have any export control on it currently. Place those notes on there, and I can save this. And when I open up the part, which I've already done a save of one, when I open up that part, I get this information here. It tells me what the limited rights are all about. That this is for company proprietary information for company use only, and export controlled license required. And I have the acknowledge the above marking, and then I can open up the part, and those markings are here. It's not putting any kind of right protection on there. There's no digital rights management that's been applied to the part. It just has this note, and it only works inside of NX. So if I shared this NX part file with the supplier, they would also get the same note. If I export this as a step file, then it will not have that note on it. So a couple of things that I really like about using PMI is when I have an assembly like this, and I am working on, say, these two parts together, and I want to make sure I have my bolts toleranced properly, I can just double click on my part file here, and it will expose the PMI that's available in the current view. And I can see that there is a 25 plus or minus 0.1 tolerance on that particular part there. But I can also link in to my part information that I would like to use. So I'm going to use the Wave PMI linker, and the source part, I can pick this as the source part, and then I can pick the views that have the information that I want to have in there. So there's a right view with the 25 plus or minus 1. I can just go ahead and select that, and when I go to make my flange the displayed part, it automatically linked in the body and the PMI, so I can work with that information directly in my part file. Go back up to the transmission, show everything. I'll turn everything off here, just bodies. Turn off my datums again and my sketches. Go ahead and undo that bit there. The other thing I can do, and this is something I really like about having running PMI, is I can do a lightweight section view, and let's say I want to do I want you to select objects to actually section, and as I'm picking those objects, they're becoming sectioned in the background for me. And I say OK, and now I have that information is sectioned, or that assembly is now sectioned, and I can go to my model views, and I have a new lightweight section view that's been created for me. If I go back to trimetric, it doesn't show the section. I can go to the lightweight section view and show it this way. I can also right-click on that. If I want to change the orientation, I can right-click and save that. And now when I reactivate when I go back to the lightweight section view, it will reorient it properly for me, or to the last place it was saved. One of the things that this tool gives me is the ability to create a section view that is a little bit non-standard. So let's get rid of my assembly constraints here. So I'm going to do a regular section view. And in the regular section view, it allows me to select a sketch section and create one on the fly. Right now it doesn't know what to section through because I haven't selected any bodies. So I can start selecting a few bodies here and then tell it to recalculate limits. if I show the preview down here at the bottom, it shows where I'm heading towards, and say OK there, and it essentially creates an extrusion that cuts through the part file and only the components that I've selected for that section. So just quickly here, what I want to do is throw in a rapid dimension, and I want to show it from one end to the other. Get that face there. And I want to pull this into a drawing view. And cancel that. Place a base view. And I get a base view with a quarter section cut out of it pretty quickly. I can do the quarter section in drafting, but it can be kind of a pain. It's not necessarily an easy to figure out way of sectioning a part inside of drafting. So I do like to use my PMI tools to create like a quarter section view such as this. And I'll go back into modeling. I can edit, of course. Edit the section. I can uncheck preview so I can actually see things that are going on. And my selected objects, I can go ahead, I want to hide a couple of them here and then add a couple more of my selected objects. And bring the bodies back. Turn my datums back off here and my sketches. And I've got more things that have now been sectioned. I go back into drafting, I'll see that I have an out of date. I'll update that and my section updates. You can use show and hide components in view to get rid of the extra springs that are in here or extra ball bearings depending on how you want to have it look. But it's a quick and easy way of creating that quarter section view. Back to modeling. One thing that it can do that is a bit strange. I'll go back into edit section. I can reverse the how it's sectioned. So I could the quarter section was a quarter section where this part was removed, and I've changed that to where that's the included part, just by reversing what's actually sectioned there with the material side and flipping that back and forth. So here I showed the ability to place a PMI in the context of an assembly. If I want to see PMI in the context of a part file, I can show it by just making that the work part. I want to go back and make the assembly the work part. I'll right click and make this the work part again. And the PMI will show up from that work part. I also can, in my Models Views tab, I can apply a PMI assembly filter. So I want to show all dimensions from selected objects. But nothing shows up quite yet, because what happened, that's the second step in this, is you have to apply it to a view. So this is my section view, so I'll go ahead and apply it here. And now, with the PMI assembly filter, I've exposed the PMI from a component part up to the top level assembly so I can see how it's put together and what the tolerances are. So when you're working in a PMI environment, personally my design approach is a little bit different. So I'm just going to create a new part file. So let's say I have this at 10 and this at 8, and I want it to be 1 inch tall. So here's my plate. None of this has got any PMI on it now, but I could just go to my PMI tab and then redimension this with a rapid dimension. And should probably change my work view to be like a top. So I could go in and again place a rapid dimension on here, but I already put a dimension on this. I know what it is. The system knows what it is. So if I go back into my sketch, I can select the sketch entity and say display as PMI. And again, display as PMI. So now in my top view, I have the two PMI entities shown. I can move those around. It's driving dimension, so I could change it if I want to. Make that 12. Without even going into the sketch, I was able to change that with editing the PMI on there. By doing so, it also exposed another dimension. So if I hit F5, that one will actually go away. F5 is refresh. If I do want to see that vertical dimension there, so maybe I have to switch to front view here, and I can right click on this and tell it to show dimensions, and I can select this 1 inch here and display that as PMI as well. Oh, the settings on this part are to display PMI on all views, so that's why it's showing up everywhere. So now I've displayed, I hit F5 to refresh again. If I go to my trimetric view, I'm going to display those three in my trimetric view, and I can see the what I've placed on there, and can edit my model directly from the PMI that I placed on the model itself. So my approach now for moving forward in a PMI world is, if I can make a sketch and expose those entities as PMI, I'll do it. Sometimes I'm going to do some hacking away at this plate where this 12 inch dimension really doesn't apply anymore. So that may have to then be not displayed as PMI, and I'll put some other dimension on there as PMI. With applying the PMI as I'm working through and creating the model, I can see where I'm going, what I've covered already. If I have a hole that needs to be toleranced and I've not quite toleranced it yet, like a slip fit or a press fit for a pin, I can go back and edit that, and then pull out information into my drawing views, and make it make my drawing cycle a little bit shorter by using the PMI that I've already placed on the model. So with that, that's pretty much all I wanted to show in PMI and NX 10. I'd like to open it up for questions if there are any. See if I can unmute the attendees here. Okay. Oops. Okay, I've unmuted the attendees. So if there are any questions out there for PMI in NX10, please shoot them my way. It's quiet.
Hey Matt, this is Ray.
Hey, hi Ray.
I shot you a question via text, but
okay.
Did you say that you could control, say, the extrude by editing the PMI dimension that you put on there?
like that
Yeah.
one right there. Basically, what happens is when you expose that as PMI and then you double click on that, it opens up the edit feature dimension. So I could change that to a 2, and now
Yeah,
that becomes a 2.
that's cool.
There is also a way to turn on bidirectional PMI edits, so that in drafting, if you notice that a dimension is wrong by a quarter inch, you can edit the drafting dimension, and it will go back and edit the model itself. I tend not to have that turned on in most environments because it can be kind of dangerous. But it's also nice you notice that you missed the tolerancing in drafting. You don't have to go back to the model to add the plus minus tolerancing on it. You can do it directly from drafting to add the plus minus tolerancing, and then that will talk back to the model itself and allow it to, or then that PMI will be seen in the 3D model, that update.
That makes sense.
On Thursday, I'm going to have a webinar that covers like the other people that are going to be looking at your PMI data in your organization, how they can go ahead and see that data, how technicians can look at your assemblies and put the assembly together without necessarily having a drawing ready yet. So that fast design cycle that we're all in, and how purchasing can see what kind of part this is. If there's no drawing, it makes it a little bit harder for your purchasing guys to see what the part is, where to send it. So I can show you the visual. On Thursday, we'll be covering some of the visualization tools to see this 3D PMI if you're not running NX and you're not a design engineer. Are there any other questions out there for this webinar?
I'll throw one out there.
Okay.
What could you show us what the assembly analysis looks like? So the stack up.
Oh, that's a tough one, Ray.
That's a whole different module, right?
It is. It is. NX back in the 32-bit world, it used to have a tolerance stack up analysis tool. Now all that has been moved into visualization. I do have a plan to cover some of the stack up analysis in a future webinar, but I need to get that kind of put together and ready for it. But it's all through the visualization tools that are available from Siemens.
Okay.
And it is a different package. And if you're running in Team Center, it makes it a little bit easier, but you don't have to be inside Team Center to make it work. It does use the JT representations and pull all the PMI in, and that PMI is then used to analyze how the assembly is put together. But you still have to tell the system how it's put together.
Mm-hmm.
So in any complex assembly, you can assemble pseudo or sub-assemblies within it, and then put those sub-assemblies all together, and then you tell the system how that all goes together, and then it will do stack-up analysis to figure out what your build rate is if you have a failure rate.
Okay, I have another question.
Sure.
If you've got the tolerances applied using PMI and you give that file to the CAM person doing the machining,
Mm-hmm.
is there a way, like I'm thinking about our gauging where it uses an MMC model,
Mm-hmm.
but right now we're physically modeling that MMC model. Would there be a way to use the PMI and a nominal model such that the geometry could be machined to a maximum material condition?
That's a good question. I'll have to get back to you on that. I know that CAM can pull in the tolerancing information, but whether or not it can then be used to machine the part to MMC instead of to nominal, I'm not sure about. I'll have to check with my CAM guy on that.
Okay. Well, we know that it's very difficult to get all those blends to go, so I would imagine that the CAM program would have similar issues, but yeah, it'd be interesting to know how that might work.
Yeah, understood. Yeah, and certainly we have a CMM in our office, and when we get neutral parts in, we'll actually apply PMI to the part help program the CMM faster. Just
Right.
It's easier to apply the PMI than it is to build the paths inside of NX CMM on the fly.
Thank you.
All right. If there are no other questions, I will close this session. I'll post this up on our YouTube channel when it's done post-processing, and if you have any questions, please feel free to get a hold of us at appliedcix.com, and we can certainly help you out. Thank you for attending.
Thanks, Matt.